Another one of the rules for taking derivatives is called the product rule. This rule does not work in the same manner that you would expect with algebra, like the sum rule and the difference rules did. Here we've got a special formula to deal with to calculate the derivative of a product. So I'm going to take a look at this down here. So if you've got some function, they've got j, and it's broken into two. Let's make our f's be this. And we'll just do this one. So g of x. There we go. So if you see, if we've got the product of two different functions, the derivative is going to be equal, the derivative of the entire function is the derivative of the first times the second. So derivative of the first is this f of x prime, or f prime of x. The second function, g of x, we just multiply by that. Plus the derivative of the second, which is our g prime of x, times the first. So again, not just the product of the two derivatives. All right, so let's try to do number 112 again, only this time we're going to use the product rule. So since we're using f of x, I'm going to let this x plus 2 be g of x, and this 2x squared plus minus 3 be h of x. So our derivative, f prime, will equal g prime of x, so the derivative of x plus 2, multiplied by the second function, the h function, which is just this 2x squared minus 3. Then we add the derivative of the second function, so d dx of 2x squared minus 3, times the first, which is x plus 2. So I'm going to take the derivatives first. Derivative of x is 1, derivative of 2 is 0, so this is just 1. And we'll leave this 2x squared minus 3 alone. The derivative of 2x squared is 4x. The derivative of 3 is 0, so the derivative of everything in that bracket is just 4x. And then we write x plus 2. So I'm going to distribute and then combine like terms. Yikes. All right. This is 2x squared minus 3. I'll distribute the 4x, so that's plus 4x squared and then plus 8x. So ultimately, when I combine these terms, I've got 2x squared and 4x, which gives me 6x squared. I've got another 8x and minus 3. And note, this is the same answer that I got when I did it with just the sum and differences.